Hello, I'm going to go ahead and do one of the practice problems for chapter 9, and it's the one for z-test. And it's number 1, and I know I already told you that, but I want to go through and show you what to look for and how to solve it. So what I'm going to do is let's look at the problem. A particular brand of tires claims that its deluxe tires average at least 50,000 miles before it needs to be replaced. From past studies of this tire, the standard deviation is known to be 8,000. A survey of owners of that tire design is conducted. Of the 32 tires surveyed, the mean lifespan was 450,700 miles with a standard deviation of 9,800 miles. Using an alpha of 0.05 is the data highly consistent with the claim. All right, the first step you need to do, I would actually go and print out the tips I have for running a z-test. And I'm also assuming that you've done all the work for 9.1, 9.2, and 9.3. So let's go ahead and look at the hypothesis. Now remember, I want to get my null hypothesis, and that is the hypothesis that will always have the equals in it. And if I go back to the problem, I see the word at least 50,000 miles. So that means I have to worry about it being 50,000 miles and greater. So then that makes this my null hypothesis. So let me think about my alternative. My alternative is my mathematical opposite. So it's going to be this one because then the mean is less than 50,000 miles. So again, this is my null, this is my alternative. So as I keep going further down, this one, I want to know what my random variable is. Okay, and I know that my random variable, I'm looking for an average because I'm using a mean. So that's going to take this one, the lifespan in miles off, and then the number of tires surveyed, because that's really just a sample size. So I've got to look at the average lifespan. And if I go back up, it says the average lifespan is in miles, not years. So it would make this one correct. So now I need to state the distribution. Anytime you have a normal distribution or a z-test, you put an n for here, and then this one is going to be your population mean. Remember that population mean is the one again in the hypothesis. Now to get your standard deviation, I'm going to bring up the calculator. Oops, not that one. This one. Nope, it won't come up. Give me just a second. There we go. So let me go back to the top of the problem, and I'm going to look at everything I need to put in. Okay. So to get the standard deviation, I need to take the population standard deviation, which is 8,000, and I need to divide it by the sample size, or excuse me, the square root of the sample size. And for this one, the sample size is 32, which is the n. So close that, and then I get this 1414.21. So I'm going to put this in here, 1414.21. So that gives me the distribution. Now I need to determine my test statistic. I know this is a z. So again, I'm going to go back up to the top. And again, let's talk about this. The reason I know it's a z, and it's going to become really obvious here, is because I have the population standard deviation, which is 8,000. So here I go. I'm going to go stats. I'm going to go over to test, and I'm going to z-test. I'm not putting in data, so I go over and hit enter for statistics or stats. It needs to be blinking so you know that it's been chosen. Now I'm going to put my population mean, which is, let me clear that whole thing, which is going to be 50,000 miles. Then I'm going to get my population standard deviation, which is 8,000. And then my sample mean, which is 45,700. And my sample size, let me move this for a second to make sure, which is 32. Okay, remember for my alternative, I put less than. So I hit enter, and then I hit calculate. All right, so let's go down. Let's go down here, and I'll bring it up. I'm going to bring both these up because they both give me the same thing. So So my z-score is, and it wants it in three places, negative 3.0, and let me again look at that, 041. Okay, and I just got that from the calculator because if you look here, oops, you can see this says z. Now my p-value, I need 4 decimal places, and it's 0.00118. So that's going to make that 0.0012. So over here, I'm going to do 0.0012. All right, what does that p-value mean in this problem? So what it's saying here is that if it's true, there's a chance equal to the p-value that the average lifespan is 45,700 miles or less. So that's what it means. So we're going to put that here. So if the null, if the null is true, there is a chance that it is 45,700 or less. And that's what we're looking for here, okay? So then my next part, oops, I'm gonna keep going down, is here. Sketch the picture. Okay, let's go look at my alternative. It is a less than sign. Because it is a less than sign, I have to pick the one that goes to the left. Remember normal distribution we talked about? Because it's less than, this is going to be the picture I need because it goes to the left. If it was greater than, it'd be the right one. If it was two-tailed, it would be this one. You will never have a between scenario for these, okay? Remember, it's less than, greater than, or two-tailed. All right, so the final part, I need to put my correct alpha value in that. How do I do that? So I go back up to the top, and it says at the 0.05 level of significance. So I'm just going to put that in here, right? So what is my decision? So I need to take my alpha and compare it to my p. So my p is 0.0012, which is a lot smaller than 0.05. So I'm going to reject my null. Remember, I put that thing on the sheet about conclusions. People eat fish from the River Nile. You need to decide which way you want to learn that so it can help you. Okay, and the reason we rejected it is because the alpha was greater than the p-value. So what can we conclude? So since we rejected the null, that means that we're thinking that the alternative is correct. So we're going to conclude it that we're finding that the tires are less than 50,000 miles. Because let's go back up to our hypotheses. I said this one was not true, and I said this one was true. So I need to conclude based on this one being true. And if you go down here, the sufficient evidence means that it is less than it. So that is how you do the first problem in the practice, and this is how you do Z problems. Again, print out the sheet I gave you and just take your time on working on the homework.